Hello students, welcome to the first tutorial in the vector series. In this tutorial, we have three main objectives. At the end of this tutorial, you should be able to get the components of a given vector. Apart from that, determine the resultant of two or more vectors. And lastly, state the direction of a given vector. Now, a vector is defined as a quantity that has both magnitude and direction. What it means is we don't only state the value of that particular quantity, but we also have to state the direction which it is going. Now, good examples of vectors include force, displacement. Most of our examples are going to work with these two, but generally you can work with any given vector using this same approach. So, for example, if you're given a force, let's say 50 newtons, the question is, well, this is the magnitude. In what direction is the 50 newtons being applied? Or if you're taught to say that a person walks a distance of some magnitude of, let's say, 20 meters, the question is, if this is displacement, then it was 20 meters in what direction? So to specify the direction, in most cases, we have to give the angle. So angles are given mostly with respect to the positive x-axis. So this is the positive x-axis. So the question is, in what direction with reference from this axis? So it can be in this direction. So to specify the direction, we give how far away this vector is from the positive x-axis. So this angle, if it is in this quadrant, or if it is this side, then we specify this angle here. So depending on what you're given, you can either determine this angle directly, or you might have to first get this angle, and then after that, use this angle to get the corresponding angle from the positive x-axis. So take note, I keep measuring the angles anti-clockwise from the positive x-axis. So that is how I get my direction. Now, sometimes it's okay for you to just use the angle. Like in this case, it's okay for you to, it might be okay for you to just use the angle the way it is here. But in that case, you'd have to specify that you are giving your angle or your direction from the negative x-axis and you're measuring it clockwise. But the conventional way is to measure it anti-clockwise from the positive x-axis. I'm going to demonstrate how to do each. Okay, now let's look at our first example. Now, let's take, for instance, you have a vector A. Let's say this is your x-axis and this is your y-axis. And then you're told that you have a vector A that is in the first quadrant. So this is a vector A. And it has a magnitude of 40 meters. So this is a displacement, 40 meters. So, and then we're told that the angle it makes with the positive x-axis is 30 degrees. Now, how do we get the components that make up this vector? Well, when we say components here, all we're saying is the parts which make this vector. Think about them in terms of steps. It can be, you can say you take a couple of steps or a number of steps along the x-axis, and then after that, you take a number of steps along the y-axis or vertically upwards. These are the steps that make up this vector A. So the steps along the x-axis are going to be, we're going to denote this as the component of A in the x-axis, and then the steps you have to take along the y-axis, these are going to be denoted as a y, or the component of A along the y. Notice that you can take your steps like this, or you can take them starting first with the ones in the y, and then after that, take those in the x. So regardless of which route you take, you still end up at 40 meters as the displacement. In this case, since the angle we're given is this 30 here, which is adjacent to the positive x, we take the root in blue. Now, how do we get these steps? How do we get these two components? Well, here what we're going to employ is trigonometry. So from trigonometry, what we have to recall is there is this common abbreviation that you guys can still utilize. So we have to look at the relationship between the side and the angle we're trying to find. Like for example, to find the x component, we see that the two are adjacent to each other. So the ratio which deals with terms of, an angle in the side which are adjacent, it's going to be cos. So if we use this part, we see that cos the angle which we're given, which is 30, is equal to the adjacent, which is ax, over the hypotenuse. And the hypotenuse is the vector A itself. So if we cross multiply here, what we now have is ax is equal to a cos 30. Now, what is a? A is the vector A, which is 40 cos 30. So from here, we can simplify this. Now, for uniformity, I'm going to give all my answers correct to 2 decimal places. Let's say correct to correct 1 decimal place. Yeah. I'm going to stick with correct 1 decimal place. Okay, so if we evaluate this, this comes out as 34.6 meters. So this is the x component of A. Now, how about the y component? Again, we come back to our diagram and then using SOHCAHTOA as well. So we see that the angle and the y component, they are opposite to each other. So because they're opposite, we're going to use this relationship, the sine. We're going to use the sine ratio. So for sine, what we have is sine, the angle is equal to the opposite, which is ay, over the hypotenuse, which is the vector itself. From here, again, we cross multiply. This gives us ay, which is equals to a is 40 sine 30. Sine 30 is half, so half of 40. This gives us 20.0 meters. Okay, so this is how we get the components of our vector A. Now, this was quite simple since the angle we're dealing with already was adjacent to the positive x-axis, so this was kind of direct forward. Now let's look at another example. Now, with this example, let's say the vector that we're given is in the second quadrant. So let's say that now the vector we're given is this side. But again, for simplicity, we can start with the fact that, with a condition, a situation where the angle we're given is this angle. Let's say this is 60 degrees. And then we're being asked to find, let's label this as B. And then we're being told that the magnitude here is 14 meters. Okay. So again, the question is, let's find the components that make up B. So again, in terms of these components, all we're saying is these are steps. What steps do we have to take for us to end up with the vector B? So we start, since the angle is here, we start by first moving along the x. After that, then we move vertically upwards, and then we reach B. So these are the steps we have to take. So the step along the x is going to be labeled as B in the x. Then the step along the y, that is going to be B in y. Now, here, there are two methods we can use. The first one, we can directly take the angle where it is, exactly the way it is. But if we take that, we have to also take into account that Bx is pointing to the left. So here we're taking to the right as positive. So this is what we're sticking with. And up to be positive, implying that anything going to the left is negative. And anything going down is also going to be negative. So Bx is pointing to the left. If we just use this the way it is, we would have to manually insert the fact that it is negative. Okay, so how do we do that? So again, SOHCAHTOA here, B in X, here the two are related by cos, they're adjacent to each other. So what we have is, we can say cos 60 is equal to opposite, adjacent I mean, which is Bx over B over the hypotenuse, which is P itself. So from here, you can, it's up to you really to bring in the negative at any point, but here I'll bring it towards just at the end. So from here, we want to find Bx, so we cross multiply here. What we now have is Bx is equal to B cos 60. So this then is the B is 14 cos 60. So this ends up as 14 cos 60. This is going to give us cos 60 is half. So this is going to be 7. But again, we're saying since Bx is pointing to the left, this is expected to be negative 7. So this is what we expect. Since it is pointing to the left, the direction is pointing towards the left. Now, how about the y component? Well, the y component is pointing up, so we don't have to bring in any negatives here. It's already pointing in the positive direction. But it is opposite to the angle, so we're going to use sine there. So here now what we're saying is sine 60 is equal to by over b itself. So it's opposite by over hypotenuse. This is b. So we cross multiply, we get by is equal to b sine 60. B is 14, so this is 14 sine 60. And if we evaluate this, we get 12.1 meters. Okay, now this is just one method where we take the angle exactly where it is here. But then there's another method. In the second method, what we can now use is, instead of having to use the angle where it is, we can maintain the fact that the standard way of measuring these angles is from the positive x. So we have to measure this angle from that positive x. Now, if we decide to use this method, regardless of what you're dealing with, to get the x component, we are always going to stick with cos. And then to get the y component, we are always going to stick with sine. That is if we are measuring the angle from the positive x-axis anti-clockwise. That is very, very important. Now, let's label this angle. Let's find it. This is 60, and we know the angles of a straight line add up to 180. So if we're given 60 here, it means that this angle in orange has to be 60 from 180, which becomes 120. Now let's try to find the x component using this angle and the y component using this angle. The best thing about this method is that you don't have to think about with the direction and so on. Just use that angle. It will insert a negative where it's supposed to be, and it won't do it where it's not supposed to be. Okay, now let's try to find Bx using that approach. Well, for that approach, what we're saying is cos gives you the x component. So we have cos the angle, which is 120. This is equal to Bx. So cos is giving us the x component over B itself. Notice that the difference here is just the angle. So if we look at this one now, we cross multiply. So what we have is Bx is equal to B. This is cos, sorry, not sine. B cos 120. And if we simplify this, B is 14 cos 120. Now, if you try this on a calculator, notice that cos 120 itself already gives you a negative, and this becomes negative 7.0. So that's the beauty about this method. You don't have to start worrying about, well, do I put a negative here? In what direction is this? As long as you've measured your angle anti-clockwise from the positive x, the negative will be implied. Negative will come out already. Okay. Now let's try it for sine. Let's see if it gives us the y component as well. So sine 120 is equals to B the y component over b itself. So again, by cross multiplying, we're saying this. B is 14, so we substitute. So again, we see that it gives us the 12.1 meters. It doesn't put a negative because here there's no negative. Okay, so this is the second method that you can use to work out the same problem. Just take into account, if you use the first approach where you take the angle exactly the way it is given, you would have to look at the behavior of the component you're finding. In what direction is it going to point, so that you insert there and the sign there. But if you take the alternative, that the corresponding angle, which starts from the positive x anticlockwise, you don't have to start worrying about the direction of your vector. It will come out with a proper sign. Okay, so this is one example. We can look at one more example before we go on to look at the resultant of vectors. Now, for our next example, let's place our vector in the third quadrant. So in this case, let's say this is our x-axis, and let's say this is our y-axis. Now, throughout, with the first two examples, the angles we were given were adjacent with the x-axis. In the first case, it was with the positive x. In the second case, it was with the negative x. Now let's look at one example where the vector we're given is not adjacent with the x-axis, but instead it is adjacent with the y-axis. How do we treat this one? Well, it's exactly the same as we did the others. There are two methods you can use here. It's up to you really which method you're more comfortable with. But for simplicity, or to just help you guys understand this concept very well, I'm always going to take the angle wherever it is when I'm working on problems. But you guys can take the other methods as well. They're supposed to give you the same answer. So in this case, the angle we're given is this, and then it is given as 35 degrees. And then we're being told that the vector itself, let's say this vector is C, it's given as 50 meters. Now the question is, what are its x and y components? So again, if you look at what we have to do, since the angle is here, we are first moving along the y now. So we're moving downwards first along the y. After that, then we move parallel to the x-axis until when we reach our end point. So if you look at this, this is this is available in this vector C. So this is C in y, and this is C in x. Now look at the difference. In the previous case, we used cos to get the x component, but now we see that the x component relates to our angle in terms of sign, because the two are opposite. So we'll have to use sign here. Then apart from that, notice that if we want to use this angle the way it is given, we have to remember that this arrow is pointing to the left. So we'll have to manually insert that negative here. What am I saying? So let's start with the x-axis, the x component. So we're saying these two are related, they're opposite to each other, so we use sine. So sine 35 is equals to the opposite is cx, over the hypotenuse is 50. So cross multiply here, we get cx is equals to 50 sine 35. So from here, we can simplify this. 50 sine 35, this is going to give us 28.7 meters. But because this arrow is pointing to the left, Cx is pointing to the left, the final answer becomes negative 28.7 meters. So I've inserted the negative because I observed that this is pointing to the left. Okay, so this is Cx. How about Cy, the y component? Well, the y component is also going downward. So we'll have to remember that we'll have to put a negative here manually, okay, with this method. So how do we get it? So the relationship between the y component and the angle, they are adjacent to each other. So we're going to use cos here. So what we see is we have cos. The angle is 35. This is equals to the adjacent, which is cy, over the hypotenuse, which is 50. Cross multiply here. What we now have is cy is equals to 50. And this is cos 35. And then 50 cos 35, we get 41. But again, this is going down, so we have to bring in that negative 41.0. So this is one way we can do it. Now, the second method, just as we did with the previous example, I'll ask you guys to try it. Just pause the video and try to see if you can use the other method, as in measure the angle from the positive x and see if you find the exact answers. Okay, so I hope you guys had time to try it. For those who just want to follow and see how it works, this is what you have to do. Well, for the second method, we want to measure the angle from the positive x, which is here, and anti-clockwise, until when we reach our vector. Our vector is here. So until when we reach this. Now, since what you're given is this angle, which is 35, we're going to subtract 35 from 270, since we know once we reach this green line, cy, the angle is going to be 270. 35 from 270, we get 235. So this angle is 235 degrees. So this is the angle we're going to use. Now remember what I said earlier on. If we're going to use this method of measuring angles from the positive x, then remember, cos gives you the x component. This is only if you're taking your angle from the positive x-axis anti-clockwise. Cos will give you the x component. Now, how does it look? So what we have now is cos, the angle, which is 235, is equal to the x component, which is cx over the vector itself, 50. Now we get cx is equals to 50 cos 35 cos 235. So if you work this one out, 50 cos 235, without putting a negative, the cos itself, cos 235 is going to be negative. So this comes out as negative 28.7. In the same way, you can see that C in Y is going to be 50 sine 235. And if you work this one out again, sine 235 is going to be negative. Your answer comes out as negative 41.0 meters. So I hope you guys have seen how to use both methods here. They're kind of straightforward with it. It's up to you which one you're more comfortable with. But I'm going to always stick with where I use the angle exactly where it is given, and then just observe the direction. But it's up to you really. Okay, but the only thing is, if you're going to use the angle the way it is, always pay attention to which ratio you have to use. Is it sine or cos? When they're opposite, you're going to use sine. When they're adjacent, you're going to use cos. But if you're going to always measure your angle from the positive x, it is going to mean that you'd have to always use cos for the x component and sine for the y component. Okay, now we've seen how to get the components. The next thing that we're going to do is how do you get the resultant? Now, suppose you're given 2 vectors or 3 vectors, and then now what we want to get is the resultant of those vectors. Well, the resultant is basically just the sum of those vectors, or a combination, a way of combining a number of vectors. What we get is the resultant. Think about it as the result. So if they don't specify the operation, take the resultant to mean the sum of 2 vectors. But sometimes they can tell you to say the difference. In this course, you're going to be restricted to just addition and subtraction. You won't look at other operations like vector multiplication and so on. All we're going to look at is either addition or subtraction. So if they just say resultant without saying anything else, then take it as addition. If they want you to subtract, they're going to specify that. Okay. Now this is what we're going to look at. Now, since these are vectors, we can't just add them the way they are. Instead, we're going to add them in terms of their components. You'd have to add the x component plus the y component and the x component to get the resultant in terms of the x component, and then add the y component separately as well. And then after that, this will give you the resultant in y. Now, you're going to use the Pythagoras theorem to combine these so that they give you the whole resultant. How are you going to use them? Well, if this is your vector for the resultant, it's going to be given by the steps in the x, which is r in x, and the steps in y, which is r in y. So from here, this is the resultant r. So you guys should observe that the longer side, the hypotenuse of a right angled triangle, is given by getting the sum of the squares of the two shorter sides. So in other words, the resultant is obtained by getting the square root of rx squared plus ry squared. So this is the method that we're going to use. Now, as an example, let's take the situations or the examples that we worked with earlier on. So let's have something like this. And then we're saying we have a person or a man who walks a series of displacements. So let's say first, this person moves like this. And then this is 40 meters. And then at an angle of 30 degrees. And then next, we have this, and then we are told that this is 60 degrees, and then this is 14 meters. And then lastly, we have this. And then this is 35. And the displacement is 50 meters. Okay, now, this has to be a straight line. It has to start from the origin. Okay, now let's say we have three vectors, A, B, and C. And the question is asking us to find the resultant of these three. So again, we're saying the resultant is just the addition or the sum of these vectors, A plus B plus C. This is what we're saying the resultant. But you can't just add them directly. To add these vectors, we need to add them in terms of their components. So the easiest way is to create a table. So we're going to have the vector A, the vector B, the vector C, and the resultant here. So now what we're saying is we're going to split this up so that we add them in terms of their components. So what we're going to get here first is the x component of each. And then after this, we're going to get the y component of each. So now notice that these are the vectors that we were dealing with in our independent examples. Now we want to get the resultant of each. So we already demonstrated how to get the components. We actually got them together. You guys can try to get them on your own again and see if you can find them. But we already worked them out. We found that for A, the x component of A, this we found as 34.6. And then the y component of A, we found this as 20 meters or 20.0 meters. And then the x component of B, we found this as -7. And then this is bx. And then by, we found this as 12.1 meters. I'm skipping the units for now. These are all in meters. Okay. Then next up, we also found what C in X was. This came out as -28.7. And then C in Y was negative 41.0. Okay. Now, once you found this, the next thing is how do we get the resultant? Easy. So I think I demonstrated earlier on how to get the resultant. Here what we have is the resultant in x, and here what we have is the resultant in y. So to get the resultant in x, all we have to do is to add the components. You have to add a in x plus b in x plus c in x. And here, notice that all we have is this plus this plus this. But since these are negatives, it ends up as 34.6 minus 7 minus 28.7. And this comes out as, this is going to come out as negative 1.1. The next thing again, for the resultant in y, again, what we're saying is we have to add ay plus by plus cy equals to r. So what we have is ay plus by plus cy. This is what gives us r in y. So if we add them, what we get, we observe that we get negative 8.9. So these are the resultants that we get. So you guys have to pay attention. Keep in mind, here we're given 3 vectors. So we added ax, bx plus cx to get the resultant. If you're given only 2 vectors, then you have to add ax plus bx is equals to your resultant. So sometimes you can be given your resultant and then 1 vector, then they want you to find the components of the other. You should be able to get them with ease. Okay, now the next step that we have to do, since we have found Rx, this was negative 1.1, and we have found Ry, this was negative 8, that was 0.9. Now let's find R. So we saw earlier on that if we were to sketch this, what we have is, this is our y-axis, and this is our x-axis. The vector, the components that we've been given, again, these are steps. Just like we have to move negative 1.1 to the left. After that, we have to move negative. This is negative. Sorry, this was negative. I went to the left. And then this is negative as well. I'm going down. So this is in the y-axis. That's why I'm going down that number of steps. So this is what I have. So this was R in x. And then this is R in y. Now, the resultant that we are looking for, what they are asking us to find, it's this displacement from there up to this point. So this is what R is. So now you guys can clearly see that to find R, this is a right angled triangle. So as I demonstrated earlier on, R can be obtained by just getting the square root. This is a right angled triangle by Pythagoras theorem. That is R in x squared plus R in y squared. So from here, we can see that R is equals to the square root of negative 1.1 squared plus negative 8.9 squared. So this comes to give us 8.97 meters. So we found the resultant. The last thing that we have to find is the direction. Well, what is the direction? In this case, the direction, since angles are always measured anti-clockwise from the positive x, we can give it from here until when we reach our vector, or we can give our resultant as just this. But to find it here, since we know what Rx is and what Ry is, we can use this angle, we can find this angle by relating these two sides. We see that again by SOHCAHTOA, tan relates the opposite to the adjacent to give us the angle. So here what we're saying is tan the angle, if we label this as theta, so tan theta is equals to the opposite, which is Ry over Rx. So from here, what you should notice is the angle is given by tan inverse. We substitute. Ry is negative 8.9. Rx is negative 1.1. The negatives cancel out. We get the angle as 83 degrees. Now, this angle, the 83 degrees we found, if I was to sketch it down somewhere here, what we see is the angle we have found is somewhere here. It's this angle here. So if this is our vector r, what we found is this angle, 83 degrees. So if you're going to give this as your answer, you'd have to say the resultant r is 8.97, and then you'd have to say 83 degrees anti-clockwise from the negative x-axis, This is how you'd have to state your answer. But since we know that by convention, angles are supposed to be measured from the positive x-axis, then you can try to get your answer or the angle from the positive x-axis. And if we get it from the positive x-axis, all we need to do is, since from here to this part, the straight line, it's 180, all we have to do is to our 83, add 180, and what we get is going to be the full angle from the positive x-axis. And if we did that, if we added, that's 180 plus 83, we notice that we get our angle as, so this will come out as 163. Yeah, not 163, sorry, 263 degrees. Now, this is measured anti-clockwise from the positive x-axis. Then we conclude that our resultant is 8.97 meters at an angle of 263 degrees anti-clockwise from the positive x-axis. This is how we fully state our findings. Okay, so this is how you work it out. I hope you guys found this video helpful, and I hope you are able to follow my approach to working out this question. Just to help you guys practice, you can try out this question. It is not very different from what we're doing. The only difference is it uses two vectors, and instead of having to find the resultant, we're given what the resultant is, and then they're asking you to find the components of one vector, and then also the resultant, the angle it makes with the positive x-axis. So you guys can try this one out, and then leave your comments or your answers in the comment section. Let's see those who get it right, and then those who struggle, you can also just check the comment section to see if there are any hints on how to work it out. Okay, I hope you guys found this video helpful. I'm going to upload another video in the series just to help you guys understand how to work out vectors. Otherwise, this was your tutor. We'll see you in the next tutorial.